I'm Carly McAvoy. Today I'm talking about simplify complex fractions, and I'm going to do it in two parts. I'm going to do the first three questions that you see here in the first part, and then the second video will have the next three, so you can decide which video or both videos if you want to watch them both. Maybe you don't have to watch that first one if you kind of can do the simpler ones. Just a quick idea about what is a complex, what is a complex fraction? A complex fraction just means you have a fraction inside a fraction. So once you have that, you've got complexity. So this is the same as saying 3/5 divided by 7/15. That's just another way to say that same thing. And you know, whenever you have a division with fractions, you keep the first term the same and you multiply by the reciprocal of the second term. And so when you look at this problem, every time we look at a complex fraction, we're going to say the first term times the reciprocal of the bottom term. If we're going to simplify it that way, that's what we do. So that's it. We can write it down as a division, but we're always going to get to that multiply by the reciprocal, so we can go directly there. 5 goes into 15 3 times, and 3 times 3 is 9. And then we have 7 on the bottom. Remember, when you cancel something, it cancels to 1, not 0. So that would just be 9/7. Sorry, I'm on the screen a little bit. In the second one, you see how I have two fractions up here on the top? Well, what I can do is just add those two together and then divide by the 1/6. So I just put those together. And I know you can use your calculator to do that. If you don't know how to use your calculator, you can watch some videos that I have on how to do that. But the common denominator here is going to be 6, and this is going to be 2/6, and this one's going to be 3/6. So 2 plus 3 is going to be 5/6. And then just like we saw before, we're going to take our top number, which is 5/6, and we're going to multiply by the reciprocal of the bottom one. Remember, it's dividing, so we're going to multiply. And so I'm going to get 6/1, and then the 6's will cancel, and that's just going to leave 5/1. I don't need to say 5/1, I can just say 5. So if you have more than one fraction, one method is to combine them into one, and then you can use the method that we saw on that first one. Another method, I'm going to redo that one. Another method is to multiply everything by the LCD. So there's two different ways to get the same answer. You see how this has 3 fractions in it? I want to find the least common denominator for all 3 parts, and that would be 6. And I'm going to multiply everything times that LCD. Everything in the top, everything in the bottom gets multiplied. So you know that 3 goes into 6 twice. That gives us 2. 2 goes into 6 3 times, so we have 3. And down here, the 6's cancel, and we would just have 1. And if I simplify that, I get 5/1, or just 5. So it's another way to do the same problem. I got the same answer, which is 5, and I like it better. So I always multiply by the least common denominator. That's the method that I prefer. Let's take a look at that method here, number 3. First, you have to decide what is the least common denominator. If you're having trouble with that, that's a different video as well. But basically, if you think about, this is 1/1. So the denominators that we have are 9 and x. That's all we have. And so when you think about an LCD, you want to make sure that every fraction is represented. So here, I want to put a 9. Look at the next one. I want to have an x. Then I have a 1. Well, 1 goes into 9, so I don't need to write the 1 down there. And then I want x, which I already have. So my least common denominator is 9x. That represents all my fractions. And I'm going to go back and do what I did in the last one, which is multiply each term by 9x. If you want, you can put an x/1, so you make sure that you know where it is. So what's going to happen here? These 9's are going to cancel, and I get x times x. These x's are going to cancel, and I get -9. Here I have 9x times 1. And here I have the x's that are going to cancel, and I get 3 times 9, which is 27. And what do I have, a plus or a minus? Well, I had a plus, so I just want to keep that sign the same. I want to simplify, and I know that to simplify in this case, I need to factor. This is a difference of squares because this is a perfect square and that's a perfect square. A difference of squares factors the following way. I say the first term goes into the first two spots. So x squared goes to x and x. These two terms have to match. And then the next one, I have to break it down. They have to match here. So that's going to be 3 and 3. And the rule is you always have one plus and one minus. It doesn't matter which one you put first or second, but you have one of each. On the denominator, all I can do is take out the common factor. When you take out a common factor, you're actually reversing the distributive property. You want to take out the greatest common factor, which in this case is 9. When I take it out, what I'm actually doing is dividing each of those things by 9 and seeing what's left. So in the first case, I have x, and 27 divided by 9 is 3. You can see that if I was to distribute that, I'd get 9x plus 27. So I haven't changed the value, I just changed the way it looked. And then my x plus 3's I can cancel because they're exactly the same. And once I cancel those, I get x minus 3 over 9 in the numerator. Okay, that's the first 3, and then I'll do the next 3 in the next video. And I hope you have